All right, hello again. I guess we'll get rolling on the next section, which is going to be a little more technical. What's been released, and I've been fairly critical of the Canada Revenue Agency, I imagine, in my last commentary. So I'm going to switch it up, and I'm going to say, in addition to looking at things gone wrong, I'm going to talk about things gone right. And here's an area where I think the CRA has actually done something very positive in the last year, in that they've released a new series of guidelines or examples or combination of those things for the software industry. And it's really the first set of real examples, I'd call it. I mean, technically in some of its policy papers, they have allusions to projects, that really just illustrate one single concept. So this is really the first CRA published project example or set of examples that I've seen since they eliminated the 130 existing project examples that were previously developed with industry, and those were all eliminated back in 2012. So again, what I'd like to do is talk about the examples themselves. If anyone's interested, these are all available from the CRA website under the SR&ED section, webcasts and seminars. You can download both the transcripts, and there's a full video with the slides and some of the things that we're going to talk about today. What I've done is that it's a fairly long session, about an hour and 15 minutes, and it goes through a lot of what ifs, including what's not eligible. I focus more on the what is eligible portions of that, and taken the various segments and tried to combine them into one or more project descriptions where continuity of ideas were going through to try to place them all together. So I'm going to try to cover the majority of the content in that video. That they spend an hour and 15 minutes. I'm going to try to do that in about 20 minutes. So we'll have to cut a little bit out, but I think we can discuss it. So what they do is they start at first by talking about the overriding parameters or general indicators of software technology and areas where there could be eligible work. So this is a nice top-down summary that I find is very similar to a series of examples that were developed back in the 1990s, I guess 1998 and 99 by CADA, the Canadian Advanced Technology Association. One of our presenters, Dr. Roberts, was actually the head of that. And I remember there was about 120 of us involved, mostly from industry, but practitioners like myself and CRA reviewers. And we spent 3 full days to develop 6 project descriptions, which really kind of set the benchmark for what is eligible in software and made it claimable, I'd say, for at least a decade after that. So I'm starting to see that again, the series starting to provide examples, and not only examples, but probably examples in the hardest area to claim, which is software itself. So they've really bitten off a big chunk, and I think they've done a fairly good job of it, and we'll talk about why. Okay, so to get started, what they've done is given a series of indicators that talk about software technology itself. What are the key areas that we're going to look at? So what I'd like to do is I'll actually read you some of the parts of different segments that they provide us, but it really explains at a very high level what the key problems are. And then gives you indicators to say to developers, these are the kinds of things, if you deal with these issues, let's explore more into there, what your experiments were and what the problems were, because these are more likely than not the areas of eligibilities. So again, it's a very positive step. So as I say, the transcript from March 22nd starts off with saying, what is technology? The technology is not a physical entity, it's the practical application of scientific knowledge of principles. Okay. As technology evolves, practical applications of these principles can be associated with products, processes, or devices to become scientifically determined facts and principles for further development. Okay. So they get a little wordy there, but they start to build a basis for some examples of how does SR&ED start, and then how does it build? I call the concept of system uncertainty. So they give us an example where they have a microcontroller or a microprocessor that can run on an operating system and any user-developed software. So really what we're talking about here is our CPU with direct machine code. So it's very, very simple. Usually you don't have much control over what you can do. The CPU is locked down. You go in, and there's not a lot of variation that you can do on it, although there is some. We compare that with an operating system. So in a CPU, the kernel is usually very small. In an operating system, the kernel will have things like memory management, I/O management, to govern the environment itself. It then creates other layers. So within the kernel itself could have process management layers. Within the process management layers, there could be schedules, which then involve different structures or concepts like queues and lists. All of these things create what this paper calls embodiments. So these embodiments or concepts can have system uncertainty on how to design them to integrate with each other. Okay, so they're providing a nice little framework here of what I would feel or list as eligible areas or what we call later technology stacks as we're going down. Okay? So what they say is if we look at the definition of technology through some examples now, new products or services are being built using or combining various technologies for creating complex applications. The trend in software has shifted in the direction of shared services, such as software as a service, platform as a service, infrastructure as a service. Okay? We see these manifest as cloud computing, which is made possible by tremendous advancements in both hardware and software technologies. From a software perspective, cloud services became possible through advancements in networking and distributed infrastructure, as well as computing. Okay? All of these developments make use of various advancements in the software technology stack. Okay? Now, the software technology stack provides indicators of various things or components that each create the basis of system uncertainty. So which language do you use? How do you design your content management services? What about your content delivery network? Methods for caching, applications, how to work with databases, the issues that we referred to on the previous page with operating systems. So decisions that we make in one area may have upstream or downstream effects that are not clearly modeled in common practice. They even talk about microprocessors. They're saying even when we use a microprocessor without an operating system, tools used to generate machine code can come from various tool sets that can create uncertainty. For example, a well-known open source electronic platform provides a tool which uses the principles of programming language to enable writing to a higher level language. Uses the principles of a compiler, turns the code into object files or machine readable instructions, and a linker to combine the object files with the library. So each of these components, the compiler, the linker, and the user interface, have some potential components of technological uncertainty related to that tool set. Right? So again, I find these very positive indicators of what could be SR&ED, because now claimants can sit there and say, well, you know what, my work parallels this in some way, or I have issues with this, and at least it gets the conversation going in a positive direction, so we're not off track. Again, so I'm going to commend the CRA or whoever developed these examples for putting these out, and hopefully they'll become more mainstream and accepted throughout all of the district offices. Okay, so basically they talk about the technology stack. The technological advancements in software can involve new or improved techniques and methods in computing to store, search, process, and manage vast collection of data or big data. The technology stack includes advancements in support of software technology tools, new or improved infrastructures like internet-driven cloud and distributed computing. Distributed computing is a really neat issue because you'll have transactions occurring in different places. So if a portion of a transaction is in one place and it gets blocked at another, what do? Do you roll it back? Do you go forward? Do you have some pause? Do you have some error correction? Again, all these factors and decisions can have astronomical upstream or downstream effects on how you store data, how you access it, and how it affects transactions down the road. Okay. They talk about likely areas would be advancements to support scaling, reliability, and availability of software-based systems. So again, downtime, all these kinds of things. These are the parameters of the metrics that ideally you want to start describing at a very early stage in your project, because it's very seldom one single objective that's the problem. It's achieving various objectives within a certain response time, within a certain cost structure, within certain memory restraints, or whatever kind of constraints you can put on the environment that then causes you to have to look at different methods or techniques or so forth. They actually finished this discussion off with a what if. What are indicative of the ineligible activities? So things related to development of the stack or improvement of that, or the methods to deploy the software are generally what we're talking about, the eligible activities. So they look at illustrate common misconceptions about technological uncertainty. First example is to emphasize that the absence of a capability does not equate to technological uncertainty. And this is one of the big problems of unsuccessful claims, that they list the features and functions of the technology as the advancements. And really, adding features and functions may be indicative of an uncertainty, but it's really not the end result or the technological objectives per se that we're looking for. Okay? So in this example, they say a company wants to build a new version of their client server mobile applications. They've got a mobile application. The older version of the application worked in conjunction with a well-known enterprise server that offered server-side push. The new version of the application was required to work in setups where the enterprise server could not be used. In the client server application, the client server responds to client requests. With the server-side push service, client applications can receive information from their servers even if they did not initiate a request. Okay? So they're basically, if they put this as an application, they said, well, this is a feature or function that we had before that we can't find on a replacement system. Maybe it's obsolete. Maybe it just doesn't occur in any of the vendor products that we find on the market. So again, the CRA clarifies that the company can't claim the lack of availability of a push capability as a technological uncertainty, because that was really just a missing feature. It actually has to identify a limitation of the technology that would prevent it from implementing or designing a push service within this environment. Okay, so again, it's done a good what if. The projects are slightly complex, but for computer scientists, I think it'll be well within the frame of what's understandable and things that almost all of them can find something that they can relate to. Okay, so to recap the overview, or what they've told us, is that effectively in general definition defining software technology, we want to benchmark existing sources of knowledge, and we're going to discuss that in the next project. So they have a separate project that's focused just on how do you benchmark standard practice, prior art, and show that we're doing technological advancement. So again, this project, to be complete, ideally we do something like that, but I don't want to put any additions to the existing CRA projects. They did provide an example of objectives that would be quantifiable, things like reliability, scalability, availability. Again, so whenever you can quantify these, what's our existing performance, how do we quantify expected performance, these things will stack up. Maybe it's cost, maybe it's memory usage, maybe all these things together are what we want to show as a combination, create the constraints that require us to do the experimentation. Now, they also outline a series of variables, or what they call the technology issues or stack issues or whatever, within different environments. So within the operating system design itself, they talk about the kernel itself, its process, its memory, its I/O management, that the process management objects itself, the schedules, the list and queues, all of which can create the system uncertainty that again creates technological advancement. In the microprocessor, as they've illustrated, differences in how we integrate use or function of the compiler, the interface, the linkers, different programming languages. If we can make conclusions that say, here's the state of the art, here's the readily available information on how to do it, and here's how we've departed from that, again, this could be strong basis of technological advancement. They also go on to provide other areas, and this is typical of the international rules. If you see the OECD rules on software, if you see the US examples on software, they're very common on areas that they say are typically involve eligible SR&ED. So they'd be specialty areas: big data, methods to store, process big data, improve infrastructure options, anything doing with scaling, reliability, and availability, as we talked about, design of that technology stack or the tools within themselves, improving those tools, and things like machine vision, research, speech recognition. Again, they can create those bases. So again, those are the flags or the hooks that we're going to look for as a potential for an eligible project, and I believe personally that this paper provides strong guidance on how that's done. Okay. The next example, and I'll qualify that these examples are kind of spread through the paper, so I've pieced them together from various parts. In the printouts, if people want to download it, I've actually mentioned each paragraph from the transcript that I pull it from, so you can rebuild it yourself and say, where's Dave getting this information here? But what the next example did is really not look at a whole project, but it really tried to focus on how would a claimant effectively show that they're going beyond standard practice, really what we call the advancement stage, addressing is something routine or is it beyond information that would be readily available to someone skilled in the art. And I would say this is more and more of a focus on every SR&ED claim than ever before. So, looking at this description itself, what we're told here is that if we take an example of a telecom software company developing an automatic call distributors, or ACDs, for voice over IP, or VoIP. They want to prevent failures in the, what they call the SIP, or the session initiation protocols, due to hardware, software, or network failures. So they're starting to identify areas or potential areas of the technology stack where these problems could be initiated or perhaps mediated. They acknowledge that peer-to-peer connections through data networks are susceptible to such failures, resulting in session disruptions. For voice sessions over data, this has an undesirable effect of loss of ongoing phone calls and call setup and progress. So we work backwards from it to say, well, one of the objectives seems to be call continuity. So can we provide, and the project doesn't, but ideally a claimant would say, well, here's our existing performance metrics, and here's hopefully where we want to prove it. Or maybe we want to maintain the existing level and reduce the cost, or some combination of that. But again, we want to start looking at what objectives can we quantify, and how will these objectives stack up to create technological uncertainties, if at all. So they say the company asserts that the objective of call continuity, continuing phone calls without reinitiating, cannot be achieved based on the standard technology base. So the real question came, well, how did the company come to that conclusion? And they say, well, the company came to this conclusion by doing the following. One, starting with identifying the technologies involved, such as SIP protocol, session description protocol, real-time transport protocol, and their interactions. Okay? So the methods to do that. They then identified what's available in the technology base with regard to peer-to-peer calling, failure modes, call setup, call progress, and call teardown. So again, not what off-the-shelf products are there that we can choose from or select, but how do those products work? What are the variables that make one product perform differently than another product, and perhaps how would that relate to our objectives? Okay? Describing any proprietary technology involved. So that's really important all the way through, whether you're developing your own proprietary technology or expanding on a black box technology of a competitor or someone else where you want to mimic that and figure out how something's working. So the information of proprietary technology is often, we know it exists, but we don't have readily available information on how to do that. So again, that could be an eligible area of research. Furthermore, they say you should identify any patents or technical information associated with how call failures are handled using the current state of technology. So again, they're giving you a bunch of issues or ideas of these are the various things or avenues that you could look at in order to assert that you're not recreating the wheel, that you're actually expanding on the existing knowledge base. Providing the technological experience of the company itself in such areas as VoIP, information theory, voice telephony, network protocol knowledge, transmission protocols, user data protocols, etc. Okay? Identifying where the current state of technology is insufficient, and having this research documented when it was done in order to establish what was done at what point in time. And this is a very important point that gets missed a lot. The real question that I face a lot is, when does the SR&ED project start? If I'm looking at 400 patents or articles on defining perhaps the state of the art, does my project start after the 400th article? Or if I can phrase a hypothesis after the 30th or 40th article, where I start to see a pattern, and then I can say, well, you know what? Here's my hypothesis, and the other 350 articles I looked at are all looking at analysis of different alternatives in order to solve this problem. I would say as soon as you can phrase the initial hypothesis and you have enough prior art, you can switch from the point of getting background information to doing the applied research. Okay? And the definition, as this paper clarifies, is the point where you can phrase the uncertainty. The uncertainty rests in the mind of the researcher. So when the research team can, as a group, say, here's what we want to do, here's what we know, and here's clearly what we don't know, and we think that's a very reasonable expectation, now everything we do from this point forward to address those issues should be part of the SR&ED project. So giving a quick example of how would we document all of the things that we've described in this example. Well, what we'd say is, well, maybe we did internet searches and we found X number of articles to identify the technology base on peer-to-peer calling, failure modes, call setup, things that were mentioned in there. Maybe we looked at different patents to look at how the state of technology was handled. Competitive products. So what existing products or competitive products are out there for TCP, all the different protocols that we're looking at. What are the methods? What are the papers? What are the known variables? You know, are there papers that talk about the vagaries of the problems in setting this up? What are the known issues? Again, all those things are worth their weight in gold to support the SR&ED claim. And they're often available, but they're often lost. So if you can capture this at the outset of the project, again, it provides a very strong structure, both for the people required to do the documentation. If we can say to a team, hey, listen, that we all agree that these are the top 5 variables that we're dealing with. So whenever any of us is doing something in the next year where we think we're helping to answer or understand those variables better, let's talk about it, because that's part of the team's R&D. And again, if that structure is communicated clearly between the manager and the team, what happens is a very effective and efficient documentation process. Okay. The next is a software security example. So what they've done in the project itself, or the examples, is they've talked about an overview example, how do we define standard practice example, and then what kind of documentation would be realistic within that framework. So we're given the last example of a software security example, where we're told that the company wants to do a single sign-on. It wants to eliminate the use of an external service. It wants to create improved reliability, cost, and maybe things, parameters such as log on time, which it doesn't mention, but which are probably relevant. So we've basically got 2 alternatives here. They're basically allowing their remote users to log in from an outside source, or use a third-party service to do this. And I'll talk a little bit about it. It gets a little technical here, but we'll talk about some of the high-level details in order to illustrate some of the things that we want. But what we'll effectively do is talk about the nature of the documentation. We'll talk about the nature of the documentation that they want us to identify. So they say that the limitation of the technology in this example is that they have a single sign-on option available with an XY cloud XYZ cloud using something called the WS Federation Protocol. The cloud's identity management trusted the Federation Service Protocol to provide security tokens. The technology base, including understanding how the XYZ identity management worked, was insufficient for the company to develop a solution to overcome the restrictions. So they say that having a black box or not understanding how the protocol worked was a block in itself. Work can be undertaken in advanced knowledge towards the development of the solution that will enable a single sign-on is deemed to be in the nature of what we're looking for eligible work. Okay? So they here really provide us an example of the work undertaken. So this is more an example of what kind of steps would be typically eligible and what kind of natural documentation would fall out of the process. So the client's not required to do extra documentation, but the client's required to maintain the documentation of what they did throughout the process. So they say that the work undertaken would involve setup of the XYZ Cloud's access control service using the Cloud Directory Service as the IT provider for a relying application to be created. A packet sniffing tool was set up to capture and analyze the user browser network traffic and log in during attempts. Cloud Directory Service was populated with user objects from a local directory service using a proprietary synchronization tool in its approach. Okay? They then go on to talk about how they discuss different relationships between the attributes and different user objects. And that the various types of information would be the source code itself, the maps of the documentation, the high-level notes, and basically evidence of failure itself. So they provide a kind of a list of documents that would go through the development process and basically say that at the end of the day, the technological advancement in this project is understanding where and how the directory service, user objects, and attributes are used within the claims themselves. How do they interact? How are they mapped to the security tokens? So again, we didn't know how the security tokens work, how to figure that out and make those two things integrate. The relationship to the cloud identity management user objects and ruling out the need to mimic any of the Federation Service specific behavior within those objects. So the combination of those objectives and the related experiments was deemed to be the eligible SR&ED. So again, this is a fairly technical document, more related to software, but again, provides, in my view, a good basis for claims itself. Okay? Now, moving right along to close up on the software side. One of the areas that's very popular right now, and that I see coming into practice is the whole area of artificial intelligence or machine learning. And there was a very interesting article by one of our colleagues' firms in Canadian Lawyer magazine, and it talked about is the concept of is artificial intelligence work patentable or protectable from an IP perspective. And a lot of the issues that they're talking about are directly relevant to SR&ED, technological advancement, prior art, what are we learning, trial and error investigation. All of these issues start to pop up, which, you know, when we hear the news about Toronto becoming a mecca or a hotbed for artificial intelligence, not only for Canada but for the entire world, the concept of us having to have clients or claimants that are dealing with these issues is becoming more and more real, and I'm seeing it all the time. And the issues in this article are actually, you know, really coming to bear and causing me a lot of concern about, is artificial intelligence eligible, and if so, how and why is it eligible? All right, so what we're talking about here is that, according to this article by Stacy Rush of Rid Up Maybe, artificial intelligence black box of decision making presents challenges for AI and machine learning innovators who want to file for patents. Practitioners need to consider the unique properties of AI to secure meaningful and enforceable patent protection. The problem with the black box or AI algorithms is that machine learning relies on training a piece of software to make decisions by providing feedback on the output it produces while processing a set of training data. The programmers create the initial structure of the software and define the feedback heuristics used to train it. But the software produced by the training process is often a jumble of weights and interconnections between nodes and a neural network that's similar to a humanly ineligible chunk of math. So it basically says that an AI system created versus machine learning can exhibit highly effective decision-making, but they do it without providing their creators or anyone else without any meaningful insight as to the logic of the system. A great example I saw of that was the Google I/O conference, which is on YouTube. And one of the presentations that they had 10 of their developers for voice software, teams from linguistics, software, mathematics, AI, machine learning, and as a team, how they spoke about the advancement they made in the past 2 years have shocked all of them and gone beyond what any of them thought were achievable in the last 20 years. That effectively they say that their voice translation can take 1,700 languages that exist, 1,700 to 1,800 languages in the world that have over 100,000 users, and in any voice, any accent, instantly translate it back and forth into any of the other languages. And this would have been theoretically impossible with any of the methods we were using, but the machines have learned it. And they basically said that the developers who take credit for these achievements have said for the past 2 years they've done nothing but watch how the machines learn. And interested to see how the machines basically learn by trying things and failing over millions and tens of millions and hundreds of millions of times. And it would be effectively what we call a trial and error process in many cases, or it could be a controlled process. And this is really the questions that we want to look at. What are the factors that determine whether artificial intelligence work is patentable and eligible for SR&ED credit, or whether it's really just trial and error investigation done by machines that can yield fantastic results? So effectively, what we want to talk about is considerations for patenting a machine learning system. One of the fundamental questions is what parts of the technology are being claimed as the invention. So getting back again to the CR examples, what parts of the stack, what parts of the technology, what components. An inventor will need to make choices about how much they want a patent to focus on protecting the processes as opposed to focusing on the final product. Okay, so what were the methods to do it, to make it happen, versus what were the final features and functions. So again, the issues that we're talking about in advancing the technology in a patent are very similar, if not identical, to advancing prior art within the SR&ED framework. Excuse me. Another issue requires the consideration of subject matter. To qualify, AI generally needs to be something more than an abstract idea. The patent offices talk about if your project or your problem is too general. If your objectives are too general, that will not be patentable. Whereas if you can be specific about what your objectives are within a specific environment, that's again where it's going to be patentable. So they talk about the things that allow you to claim a strong patent. And I would also argue a strong SR&ED claim would be specifics about the hardware, i.e. sensors, remote devices, autonomous vehicle controls. What are we dealing with? Processor architectures. Be specific about how this works rather than saying, well, this is to work on all processors and trying to make a generic patent or a generic advancement, again, that doesn't really tie to specific variables. They want specific detail. And the word specific is about everything, about the training data or how the data was processed by the system. They want that data on structures, the learning algorithms, how the heuristics were being used for decision making, and maybe any other technical things that they've done for the functioning of the computer hardware or software itself within that. Okay? So really what we're talking about is that there's a series of tax court cases that show that this may or may not be patentable in the U.S., but the difference tends to be specifics. And I would say that this is probably going to equate in the SR&ED claim to the claims that are successful in the AI field and those that are not. Okay.
Thank you, Dave.
Actually, I just want to finish.
If there are any questions on any of this?
I'll just clear up.
Sorry to cut you off. Go ahead.
Sorry, I realize I'm going a little over. I'll just finish off one last point here. And one of the things that I think one of the founding things that's really interesting is Wikipedia provided a good breakdown of heuristics. So the real thing that I think is going to determine whether AI is in is really the design of what they call the heuristics. And heuristics is really a Greek term meaning a technique for solving a problem more quickly when classical methods are too slow, or for finding an approximate solution when it's impossible to find an exact solution. And that's effectively what AI is doing. It's trying various solutions until it finds the best one so far. And there's a lot of trade-off criteria that they talk about. Things like optimality, completeness, accuracy versus precision, execution times. And these will all be providing parameters in there. In the case that talks about some of the examples of the algorithms that could be in there. A simple problem. So we take a simple problem and then we try to build on it. They talk about a traveling salesman problem. So this is a problem faced by logistics companies. What's the best way to send my carts out if I'm UPS in order to do things most efficiently? These are the kinds of problems that they call intractable, that after a certain number of points, they become almost infinitely complex, where really you can only optimize a solution. You can never get the best solution because it becomes statistically impossible to calculate. So again, all these things are positive indicators. And again, I'd like to commend the CRA on a good, in my opinion, a good first attempt on these descriptions, as well as get the community aware that the AI and new areas are coming out that probably need some kind of descriptions or guidance as well in order for us to claim efficiently. Thanks, I'll pass it off at that point.
Any of the other moderators have any comments before we open it up to any questions? You'll see that there's another polling question being put up, so if people would mind answering those. We haven't had great participation in those, but perhaps more people can partake in those. So I'll just read it out loud. Do any of the clients have concerns on eligibility of claims involving machine learning or artificial intelligence? So the first one is I don't have any claims. Second one, not at all concerned about eligibility, slightly concerned, moderately concerned, or considerably concerned. I think it's an interesting area, and as David says, it's one that's really evolving. And I think that a lot of the claims may actually be too early to tell, shall we say, because they're just CRA is just starting to get into them. Be interesting to see how well they do in this area. So people, just another couple minutes. I don't see any questions. If anyone has any questions. Anybody have any comments? This is a very technical area, I understand that, and I did actually watch the webinar and look at the examples, and trust me, David did a much better job of going through it than CRA did, but it is useful from the perspective that at least CRA is trying. I'm not sure how effective they were with these specific examples, but they are trying. And maybe they'd mean a lot more to more technical people that are intimately familiar with this area. Okay, seeing there are no questions, I am going to quickly just end the poll and post it. People,
Thanks,
3. Go ahead, David.
I just got a note that Todd Louie was going to present next, but he's had a family emergency, so I guess we're gonna bypass his presentation, and maybe we'll give it a 2 or 3 minute break, and then I'll start the next one in roughly say 2 to 3 minutes.
Let's do it in 4 minutes, and it's exactly 3:10.
3:10 it is. Okay.
4-minute break for everyone. Feel free to do the poll. It'll be open for the next 2 minutes. Thank you.